Good morning. Today you are going to be learning 6.6 trapezoids and kites. This is the last section of chapter 6. Your learning target is I can understand and apply properties of trapezoids and kites. So we have an essential question. How are diagonals and angle measures related in kites and trapezoids? So we have properties of trapezoids. A trapezoid is a quadrilateral. Notice it does not say it is a parallelogram. With exactly one pair of parallel sides. The parallel sides are called bases. The non-parallel sides are called legs. The base angles are formed by the base and one of the legs. In trapezoid ABCD angle, A and B are one pair of base angles. So they are formed by this one base and each of the legs. They are not congruent though. And B and D, angle C and D are the other pair. So these two are. I color code them so that way it's a little easier to tell. Oops. So these two go together, not congruent. And these two go together, not congruent. If the legs of a trapezoid are congruent, then it is considered an isosceles trapezoid. So if these two legs were the same length, it would be an isosceles trapezoid. It does not look like they are the same here. So, if we have specifically isosceles trapezoids, we know some things about them. If a trapezoid is isosceles, then each pair of base angles is congruent. So, like I was saying up here, this is not congruent legs, which means that the base angles are not congruent. But if you do have congruent legs between your parallel bases, then the base angles are indeed congruent. So angle G is congruent to angle H, and F is congruent to angle J. If a trapezoid has one pair of congruent base angles, then it is an isosceles trapezoid. You just have to know one pair of congruent base angles. It does have to be a trapezoid first, so you need one pair of parallel sides. And then if you have one pair of base angles congruent, then you know it must be isosceles, so these two sides must be the same. And then lastly, 6.23, a trapezoid is isosceles if and only if its diagonals are congruent. So it's kind of like a rectangle in that its diagonals are congruent, a square also, I suppose, but it doesn't have any other rectangle properties. So these diagonals, QS and RT, are the same length. That's why we need to know, guys, when we're finding if something is a rectangle, that it is first a parallelogram. Because checking the diagonals could actually be finding you a trapezoid, not a rectangle, if it's not a parallelogram to start with. So let's do some solving. We have example 1. We're going to use properties of isosceles trapezoids. Each side of the basket shown is an isosceles trapezoid. It gives us that the measure of angle JML, that's this guy, is 130, and KN, that's this section, is 6.7, and MN is 3.6. Okay, so it asks us to find MJK. Now, it didn't say anything about this above, but because of the way it is set up, since this is an isosceles trapezoid and these legs are the same and base angles are congruent, if this is 130 and this is 130, we technically know, even without a theorem, that these two, angle J and angle M, must combine to make 180 degrees. Because this is still a four-sided shape, we know that the total degrees in this trapezoid is 360. So if you preferred, you could actually call both of these angles x, because they must also be the same, and say x plus 130 plus 130 equals 360. Or you can do this sort of shortcut here, and you can find the measure this way. I don't really mind which way you do it. Just keep in mind that there are a couple options. And then to find JL, that is this other diagonal. Since you know the diagonals are the same, all you have to do is add the two pieces given to you. And this will give you 10.3 feet, which technically is MK, but since the diagonals are the same, this is also JL. Okay? So we're going to go ahead and do the U try. You can pause me and try it yourself. I'm going to go ahead and get started. So we have each side of the basket shown is an isosceles trapezoid. So EH and FG are the same. That means these base angles, these two and these two, are congruent. We'll probably end up using that. They give us FGH is 124. They tell us FI is 9.8, and they tell us IG is 4.3. So we are trying to find EFG, that's this guy here. Once again, y'all, you can use either the idea that this is also 124 and have x plus 124 plus 124 equals 360, or you can just know that these two, and by those two I mean the angles, not the side lengths or the diagonal lengths, the 124 and the angle we are trying to find equal 180. So we solve. And once we solve, we end up getting 56 degrees for that angle. All right, IH, we actually have extra information than we need. Once again, there's not really a theorem about this, but since you know the diagonals are the same, you are also guaranteed that this part of the diagonal and this part of the diagonal are the same. And since we're trying to find IH is simply 4.3. And it is in feet, so 4.3 feet. All right, moving on. We have the midsegment of a trapezoid. This is another thing we know. The midsegment of a trapezoid is the segment that connects the midpoints of the legs of the trapezoid. So the midsegment of the trapezoid is parallel to each base, and it measures 1/2 the sum of the lengths of the bases. Guys, basically, it's just the average, okay? These are midpoints. That means that this part and this part are the same because it's cutting that segment in half, and that these two are the same. It does not have to be part of an isosceles trapezoid. It just has to be a mid-segment. Now, the cool thing is you can actually find the size of that segment if you know these two, or vice versa. You can actually find the size of any of them if you know two of them. So we are going to go ahead and do that. Now, this one is a little bit tricky because you're not finding the middle one. The middle is a little more straightforward, but right here, sorry, I didn't scroll down. This one's a little bit tricky because you're finding an outer one. The middle one's a little more straightforward to find because it's just an average. So you have a couple options. You can think through it. On all of these, you can just see, okay, this is counting up by 10, right? So if we count up by 10 again, because it's getting bigger, you can tell that. That means x will equal 40. If you do not like the idea of just thinking through it, you can actually set up a formula. You know the average of the outer, so 20, plus x divided by 2, because that's an average. You add the two things, you divide it by how many there are. This will have to equal 30. Now, this is the algebra setup. To solve this, I'm going to multiply by 2 on both sides. This gives me 60 equals 20 plus x, which means x is equal to 40, which we already solved for by just thinking. Okay? So keep that in mind, that there's multiple ways to solve. When you try this, you try. Okay, I'm going to get started. They tell us that this is an isosceles trapezoid. Can be helpful with this mid-segment. So this JK is a mid-segment, meaning you can find some lengths. You're trying to find XY. JK is 18, WZ is 25. So you can either think about the subtraction method, so 25 minus 18, because this is bigger, so you're going smaller as you go, means that you subtract 7 and x will equal 11. Or, like we did the last time, we know that our little formula here finds the middle, so 18 equals the two outers added and divided by 2. And then you can solve and you get the same thing if I multiplied correctly. So whether you do the algebra or just think through it, you get that x equals 11. Okay, those are all our properties of trapezoids. Let's keep pushing on. We have properties of kites. A kite is a quadrilateral with exactly one pair of consecutive congruent sides. So if you recall, this is also a thing about rhombuses, consecutive congruent sides, but only one pair in a rhombus do you need. Second thing about a rhombus is you need to have a parallelogram. Okay, so a kite has two pairs of consecutive congruent sides. Unlike a parallelogram, the opposite sides of a kite are not congruent or parallel. So all of these that we're talking about today, trapezoids and kites, are not parallelograms. They're just quadrilaterals. So they are a separate thing altogether. So if you look here, you have consecutive sides congruent and another pair of consecutive sides congruent. So it says if a quadrilateral is a kite, then its diagonals are perpendicular. We've seen this before as well, but it's true also for a kite. If a four-sided shape is a kite, its diagonals cross at 90. Another thing we know, if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. So not both pairs, but one specific pair. That pair is the pair between the consecutive congruent sides. So you notice where I have red and blue marked out. These two, let me switch over. These two angles are congruent. The other two are not. S and Q, not congruent. Just angle P and R in this case. It's where the consecutive congruent pairs come together, okay? They match up with the other set. So, we're going to do some solving, and then we will call it good for today. We have, if WXYZ is a kite, find the measure of XYZ, so that's this guy here. Notice it is the non-congruent angle, okay? It's where the two pairs of consecutive sides come together that are congruent. So this angle Z is 121 degrees, and we are trying to find this. Which, since it's labeled Y already, I'll just call it Y in my problem. Since it is a four-sided shape, we know that it equals 360, and we solve. So when I add those three numbers together, you can just plug that into a calculator. You get 315 plus Y equals 360. So y is equal to 45 degrees, which is the measure of angle x, y, z. Notice it's different than the measure of angle w. All right, we're going to move on. We have a different type of problem. We are solving for NP. That's this segment. Now recall we have a theorem that tells us that we have 90 degrees here. So we can actually use Pythagorean theorem. We can solve for this hypotenuse, and since it's marked the same as NP, it'll be our measurement. So we have 6 squared plus 8 squared equals c squared. So 36 plus 64 equals c squared. So 100 equals c squared. So that length of MN is 10, which is the same as NP. Okay, another you try. You can pause me and try it. I'm going to keep going. Similar to what we just did. We have a kite. We are trying to find the measure of CDE. That's this guy. I'm going to call it X because we don't usually say D as a variable. You can write D if you want. We know that angle C and E are congruent because they come together at the consecutive congruent sides. So angle E is 130. And then these four add and equal 360. So we do this math. When you do the addition, you should get 324 plus x equals 360. And you solve, and you get x, which is the measure of angle CDE, is 36 degrees. So I'm actually going to write that up here, since that's what the question wanted to know. All right, lastly, we have another Pythagorean theorem. They want us to find KL. Once again, it's the same as KJ. So if I want to solve for this, we've got 90 here within a kite. The diagonals cross at 90 degrees. So we solve Pythagorean theorem for KJ, which is the same as KL. So C is equal to 5, which means that KL is equal to 5. All right, before we finish up, I do want to flip over to the very first page and finish filling out that chart. So I'm going to go there now. You can pause me if you needed to, or go back. We're going to fill this out. We have 3 more boxes to fill, because that was the end of our notes. A plane trapezoid does not have much that we can say. It has 1 pair of parallel sides. That's it. So we're going to check that off. 1 pair of parallel sides. That's all we know about a plane trapezoid. Isosceles trapezoid has quite a bit more. We know in an isosceles trapezoid that the diagonals are congruent. We know that we have 1 pair of parallel sides. We have that legs are congruent, and we know that base angles are congruent. So that's quite a bit for isosceles trapezoids. All right, and then a kite. We only have 1 thing to check, but then we're going to write a couple other things. We know that the diagonals are perpendicular, and then 2 other things that we know that aren't on the chart. There are 2 pairs of consecutive congruent sides, and there is 1 pair of opposite congruent angles. Okay? So I wish there was check boxes for those, but there's not. And then we need to draw our pictures. So let's take a look at that. These have a little more than what we had seen before. So down below we have our trapezoid. The plain trapezoid doesn't have much going on. You can draw it like this. There is one pair of parallel sides. That's all we know. Something else that I want to write out before we get too far is that these are not parallelograms. Okay, so not everything that we know above is true. These are different four-sided shapes. Isosceles trapezoids has more going on. In an isosceles trapezoid, you know that the legs are congruent. You know that we have parallel bases. And we know that the base angles are congruent. And then one more thing that we know, I'm going to draw another trapezoid for us, is that it's not a very good trapezoid. We know that the diagonals are congruent. And it's kind of hard to mark, but the full diagonals, not just a part, are congruent. All right, and we have one more shape. We have kites. It looks like a kite that you would fly. We know that a kite has to have a pair of consecutive congruent sides. Where those sides come together, we have a pair of congruent angles. And then the last thing we know is that the diagonals cross at 90 degrees. And that's everything we know about all of these four-sided shapes. All right, hopefully you guys can get these notes written down today, and I will see you tomorrow. Have a great day.